Okay, hello everybody. Welcome to my channel today. I'm Kevin, and once again, welcome back to the topic of biopsychology. Well, to be exact, it's not really biopsychology right now, but rather biology alone. So, the reason I'm talking like this is because today we're not going to discuss anything about mental or behavior, but the biology system alone. So you guys already know that in the last topic we've already talked about the human evolution and evolution theories of Darwin, of Charles Darwin. So today we're going to talk about another aspect of these theories, which is not really focused on human, but we're going to focus on the cause of human evolution instead. So this means we are going to talk about the history of evolution, the way that people usually use to aspects of the earth, of this world, how it evolved, the species change in the history based on their fossil records and research before we dig into how that human emergence in this world. So basically, it's a little bit about history and biology all together. All right. So, let's start. Firstly, we need to talk about how that people understand about the history of evolutions. Of course, this is based on the theories of Darwin. So, by studying the fossil records and comparing current species, humans have looked back in time and pieced together, let's say, some history of the evolution and, of course, about the evolution of our own species, which is, deeply related to other species, surprisingly. The course of human evolution, as it is currently understood, is summarized in the terms the evolution of vertebrae, which is the first stage that form up the vertebrae that help humans to survive, then the evolution of amphibians, the evolution of reptiles, and then the evolution of mammals to finally lead to the emergence of humankind. But we are not going to talk so deeply on humankind right now. We're just going to focus on how that amphibians, reptiles, and mammals appeared after fish, right? So, first, we need to understand when everything started. So, complex multicellular water-dwelling organisms first appeared on this planet about 600 million years ago, and about 150 million years later, the first chordate evolved. Well, for those who don't understand, chordate is the term to describe species or organisms that have nervous system or the nervous line at their back. And right now, we usually have another term for it, the spine, the bone in our back. Of course, it's not really the nerve, yeah, it's not really the nerve in the back, it's the nerve and the bones that protecting that nerve. The cortex is the type of animals in the past that don't have spine. It's only the nerve line, all right? The nerve strings that, let's say they deliver information throughout the body from the brain. They have that nerve, but they don't have the bone. Right? They don't have the bone, which we call spine now, to protect that nerve. All right. And right now we still have a nerve. Well, let's say it's around like here, and it's going back to it's going down our back. That is where our nerve is, and that is why we are also a type of cortex. But the difference is that cortex don't have the bone like we have to protect that nerve string, and therefore they are more vulnerable when being attacked from behind, or maybe not behind, but from above to be exact. And just as I said, there are animals with dorsal nerve cords, which is the large nerve that run along their back or the center of the back to be precise. And we could also call that place the dorsum. They are one of the 20 or so large categories which geologists usually use to group species into, which means that this is a type of animal. For example, this animal is one of is included in the type of chordate. Yeah. So the groups or the categories, yeah, the categories to name. or to identify groups of species. The chordates was one of the most largest of them. And well, the first chordates with spinal bone, which is the spine we use to talk about, appeared, well, let's say about 25 million years later after the appearance of the first chordates. The spinal bones are called vertebrae, and the chordates that possess them are called vertebrates. And because we have spine, we have spinal bones, and we have the nerve string, or well, yeah, let's just say it's the nerve cords, right? Because we have that, we are one of one kind of a vertebrate. We human are one kind of vertebrate. The first vertebrates were primitive bony fish. Today, there are seven classes of vertebrates, three classes of fish, plus amphibians, reptiles, birds, and mammals, which is not fish, of course. Recently, an important fossil was discovered in North Canada. Well, this fossil is over 375 million years old, from the time when some fish were starting to evolve into four-legged animals to, well, live on land instead of just water. And along with the scales, teeth, and gills of a fish, it has several anatomical features found only in land animals. So, to be precise, these fossil records show the shape of an animal that is a little bit like fish and a little bit like land animals, like dog or something similar like that. And in short, is just the type of link between fish and land vertebrates predicted by the theories of evolution, which was introduced by Charles Darwin. Now, after we understand the base of it all, the occurrence of vertebrates, which was the ancestor of human, now we're going to talk about the phases from the first vertebrates into amphibians, then to reptiles, then to mammals, and of course, we're not going to talk how mammals done to human, of course. So, well, about 410 million years ago, the first bony fish, which is a vertebrate, which was a vertebrate, start to venture out of water, and they change the shape of their bodies to breathe, to have lungs, to breathe in air. Fish that could survive on land for brief periods of time had two great advantages, which is the advantage that amphibians have because, well, they are amphibians, of course. Firstly, they could escape from the stagnant pools, for example, like traffic jam underwater. Yeah, just like that. So sometimes when you are a fish, an amphibians that live in a lake, and your lake run out of food, you could just simply go to the land, travel to another lake, and then get down to find more food. So, well, firstly, they can get out of water and move more freely, move across the land. And the second advantage is that they have more access to terrestrial food sources. The advantage of life on land was so great that after time, with the flow of time, the natural selection started to transform the firm and the fins and gills of bony fish to legs and lungs respectively so that they could live on land. And so it was that the first true official amphibians evolved about 400 million years ago. Amphibians, for example, frogs, toads, salamanders, in the larva form, which means when they was just been born out like a few seconds, they have to live in water and water alone. After a few months, when they grew up and mature, they can live on land. Only those who are already so big, like the adults, alright, the adult amphibians can survive on land. The children, the young amphibians cannot live on land because they cannot breathe. They have to wait until they're old enough to breathe on the land, right? To breathe airly. I don't know how to describe that. Yeah, just understand that. It's just like that, right? So after the evolution of amphibians, there is the occurrence of reptiles. Reptiles, for example, like snake, they occurs about 300 million years ago, and they evolved from a branch, a small part of amphibians. Reptiles were the first vertebrates to lay shell-covered eggs, which means they just simply they born with eggs. They lay eggs, not like the whole, yeah, not the whole child, not the whole body, but an egg, and wait for that eggs to hatch. So the reptiles were the first vertebrates that lay shell-covered eggs and to be covered by dry scales. Yeah, you see, snakes have their scales. And both of these adaptations reduce the reliance of these animals to the water environment because they don't need to lay, well, to born, to breed underwater anymore. They can just simply lay an egg on the land, and then when the baby animals born out, they were already, let's say, even when they are still baby, but they are already big and mature enough to live on land. And another advantage is that reptiles like snakes have the scales that is so hard and they cover all of their skin, which means they don't have place for water to get out from the skin surface. And that is why when a snake born out, it can live far, far away from a water source because it don't really need to drink any drop of water for a long time because it don't lose water through skin like human does. And well, the first state of its life in the watery environment of a bone or leg is not necessary for the yeah, for the reptiles. It spends the first state of its life in the watery environment of a shell-covered egg with nutrition already included when its mother born it out. And once hatched, the reptile can live far from water because its dry scales greatly reduce the amount of water lost through its water-permeable skin. Now, we're going to talk about the evolution of mammals. And you'll see amphibians evolved from a branch of vertebrae. And then reptiles evolved from a branch of amphibians. And now you understood that mammals will evolve from a branch of reptiles, not reptiles evolve from mammals. So understand this order. And well, about 180 million years ago, during the height of the age of dinosaurs, a new class of vertebrates was evolved from a small part of reptiles, one line of small reptiles to be exact. The females of this new class fed the young with a secretion from special glands called mammary glands. You know, like the chest, right? They breed with milk, the secretion, which means the liquid, the milk, right? And well, the females of this new class will fed their children like that. And the members of the class are called mammals after the name of that glands, the mammary glands, which is the place on our body that can produce milk, okay, for the woman. And eventually, mammals stop laying eggs. Instead, they cover, or you could say, they nurture the children, inside their own body with the watery environment. And until the baby was mature and big enough to be born out and live successfully, the duck-pilled platypus is one surviving mammalians, mammalians, sorry, sorry, mammalians that can lay eggs, not born out, so right, yeah, not born straight out the child. Well, spending the first stage of life inside its mother bodies have a lot of advantage compared to laying in an egg. Firstly, it provides a long-term security for the children or for the baby so that it can grow up safely until it was at some level mature enough to be born out without worrying about too much dangerous, just like when it was just simply it was just simply born out a few seconds. So the comparison is a little bit hard to understand, but yeah, that's how it is. And well, today most classification systems recognize about 20 different orders of mammals, and our humankind was involved in the orders of primitive. We human, in our usual humble way, name our order using the Latin term primus, which means first or foremost. Well, primates have, primates, not primitive, all right? So primates have proven particularly difficult to categorize for scientists because there are points or there are so many, well, single characteristics that was involved in both the primates and the other kind of animals, not just mammals, but even reptiles and well amphibians. But right now they are not so much like that. We just need to compare between between the primate primates, and the other kind of mammals. So that it is quite hard to recognize what is primates and what is another type of mammals, because sometimes there are characteristics possessed by all primates, but it's also included in other animals. And usually, usually the characteristics that happen in one is that occurred in one primate will not be seen in another primate. So, in summary, it is so hard to recognize primates for scientists because there are not really there are just simply almost no single characteristics that appears among the primates alone, but no other animals. What appears among all primates will usually appears in other animals, and what that don't really appears in other animals, but one primate have will usually not occur in the other primate. So that's the difficult part. There are no same points. There are no real connection. It's really hard to recognize and to categorize primates into that group because of that. But well, most experts agree that there are still about a dozen families of primates, a dozen groups of primates. Members of five of them will appear in what I say below. Firstly, it was ape. Then it's going to the second is the old world monkey. The third is the new world monkey. The fourth is the prosimian, and the final families of primate is hominin, which is human. So we're going through all of these types, of course, just slightly because we are not going to talk so deep into human. So, well, apes, for example, gibbons, orangutans, gorillas, and chimpanzees are thought to have evolved from a line of old monkeys. Like old monkeys, apes have long arms and wrapping feet that are specialized for arboreal, or you could say treetop travel, which means they were specially built to climb tree. All right, and they have opposable thumbs that are not long enough to be of much use for the precise manipulation of objects. But well, unlike old monkeys, though, apes have no tails and they can walk on 2 feet. They can walk straight just like humans for a really short period of time, and for a short distance, of course. Chimpanzees are the closest living relative of humans. Almost 99% of genes of chimpanzees will be identical in the two species. Chimpanzee sequencing and analysis consortium. But, well, however, the actual ape ancestor of human is likely long forgotten and extinct. Alright? So, well, that's all I want to talk with you guys today about the theories of evolution, the history of evolutionary animal. Yeah, the evolutionary history, sorry, and how that from first they evolved into vertebrates, then they evolved into amphibians, then the reptiles, and then they evolved into mammals. And of course, in the next videos, we're going to talk about the emergence of humankind. All right. So that's all I want to talk to you guys today. Thank you for listening, and I'll see you guys in my next video. And I think it's time for us to go by then. See ya. Bye bye.